Hi everyone, one less video for section 3.1. I apologize how these are not professional videos, but I am not a professional videoer, video, whatever it would be. And they're just me. So hopefully with my faults, you can kind of laugh at me as I screw up, because I am not a professional video maker. And I just kind of work through what I get, and you get what I do, so it is what it is. But anyway, we're going to continue 3.1 again, and I like to keep these videos short, and so we're going to do just a couple examples here. And we've talked about quadratic functions. We've taken an equation and we've graphed them. We put them in standard form so we could pull off that vertex. We saw a shortcut on how to find that vertex with the little minus b over 2a. But sometimes we have information and we want to get a quadratic. So we are going to determine the quadratic if the vertex is 1, -5, and the y-intercept is 3. Okay. Or what we could have done is we could have been given a point that it goes through, so depending on what information you have. So just to kind of refresh our minds, we have a vertex, so it might be useful to start with our equation in that ax minus h squared plus k form. And now what I can do is I can substitute my h and my k. And so I have ax minus 1 squared minus 5. Okay, I still don't have my a value, and that's where this extra piece of information is going to come in. Now if you have the x or the y-intercept is 3, that tells you that it goes through 0, 3. Or maybe they gave us a different point. But you're going to have a point that you can use. Notice this will be your x value, this will be your y value. So I'm going to substitute this in where I see x, and this is going to go where the y is, but we don't have a y, we have f of x. So remembering f of x is just a fancy way of saying y. So we will substitute in the 3 and that 0. And we're going to do some algebra so we can solve for that a. I'm going to square this piece here, so 0 minus 1 is -1, squared is 1. So I have that 3 is equal to a minus 5. I'm going to add 5 to both sides, and I get that a is 8. So the equation, or the quadratic I have, is 8 x minus 1 squared minus 5. So there it is in standard form. If they wanted it in general form, that would mean I needed to FOIL this out, distribute the 8, combine all your like terms. And I'm sure you guys could do that. All right, let's see here. Let's say that I have a farmer has 2,000 feet of fencing to enclose a rectangular pen. Rectangular pen. Okay, one thing I am not good at is spelling, so please overlook anything I misspell, which may happen from time to time. Okay, but anyway, we have this farmer. He has 2,000 feet of fencing to enclose a rectangular pen, and we want to know determine what the dimensions will be of the pen to maximize, I'm going to abbreviate maximize, the area. All right, so there we go. We have a word problem. And I know students hate word problems. So we will look at that, and the first thing that sets in is panic. The second thing is we're going to have to do this anyway, so we're going to do it. And so let's see, we have 2,000 feet of fencing to enclose a rectangular pen. So I'm going to draw a rectangle. There's my rectangle. And I'm going to label my dimensions because after all, I'm looking for dimensions. So we can call them X and Y. We can call them length and width. I'm going to use X and Y. I suppose I should have switched my X and Y's around because Y usually goes vertical, but okay, it really doesn't matter. And I have 2,000 feet of fencing, and I want to talk about area. So I do know that area is X times Y, because it is a rectangle. I also know 2,000 feet of fencing. The fencing is going to go around the pen. It's not going to fill up the pen. So that's my perimeter. So 2x plus 2y is equal to this 2,000. I'm still kind of just playing here. Got my information. I want to maximize area. So I'm going to have to work with this. However, I have two variables here, but I can use this information to turn this into something with just one variable. So I'm going to, first of all, divide everything by 2. So x plus y is 1,000. I am going to solve for y, so y is equal to 1,000 minus x. I could have solved for x, it really isn't going to matter. So I'm going to put this in for my area. So I have area is equal to x times 1,000 minus x, or 1,000 x minus x squared. Or writing it in decreasing powers of x, I get that negative x squared plus 1,000x. And then I'm like, okay. Now this is where the analyzing part comes in for math analysis. We have to look at this and do some analyzing. And we should be thinking, ding, 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 I have an x squared. Oh my gosh, it is a quadratic. What do I know about quadratics? Well, they're parabolas. They have a vertex. I could find it if I wanted to. I'm looking for the maximum. Oh, this should have a maximum value, does it? Yeah, it does. Look at that leading coefficient is negative, so that means it's going to open downward, so it's going to have a maximum value. The maximum value happens when x is equal to that negative b over 2a that I learned in the last video. Okay, I might not have it memorized yet, but I'm getting there. Negative b, so that's a negative 1,000 over 2a, so that is 500. So that tells me it happens when x is 500. Well, x represented a dimension, or one of my dimensions, so I have half my problem so far. So I know that x is 500, so how in the world do I find y? So then I start looking back. Y is 1,000 minus x. So I get 500. So in other words, the dimension of a rectangle that gives me the biggest maximum area is when my x and my y are both 500, or I have a square. So this is where all of these applications of quadratics come into play. And a lot of times when we have word problems and we end up with quadratics, we start thinking to ourselves, what do I know about a quadratic? I know it's a U shape. It has a maximum or a minimum, depending on if it opens up or if it opens down. Sometimes you will be given information, like you'll have something that is a quadratic, but you don't know what the x's and y's or anything like that is. You get to put where the vertex is yourself. All you know is there is a vertex. So there's those kind of problems too. And I'm sure you will find some of those in the homework assignments. If you're still struggling on some of this stuff, please email me, ask me some questions, let me know what you're understanding, let me know what you're not understanding. I want you to get through this material. I want you to become a stronger mathematician. I want you to understand the notation better. I want you to be able to see, to read, to picture things in your head. I want those light bulbs, those little ding ding dings that you might laugh at me when I do that, but it's like those are the things that happen in my head. I see this quadratic and I'm like, oh, it's a quadratic, it's a parabola, it opens downward, and those sorts of things come to my head when I see these things. That's where you need to start getting to. Okay. The next video will be on 3.2. And again, as we go through chapter 3, we're going to be getting lots of information from the text. This chapter is by far very informative, and it is very time consuming. So just be patient with yourself as you work through these problems. And I'll see you in the next video.